using, that's 3.2, using the equations of motion, calculate the speed at which the ball was projected upwards. Okay, the ball was projected from here to there. So you're looking for the speed, right? What information do you have? You have the speed up there. So that is, you could call that final velocity. So VF is equal to 0 meters per second, right? And then what is your initial velocity? Initial velocity is what you're looking for, right? Because the ball started at this velocity, that's initial, and that is the final. So we're gonna go V initial is what we're looking for. Okay. And then what other information do we have? We also have like the vertical distance. It traveled, so we have we could say delta y is equal to 5.89 meters. All right. What else do you have? Information. You have gravity. Gravity you always have. So that is g, acceleration. That is minus 9.8. Now, yeah, square meters per second. Now, guys, please pay attention to what I'm about to say. We all understood why we have this zero there. This is what we're looking for. Now let us look at this. This is called displacement. Sorry about that. Displacement, right? Displacement is a vector. Displacement has magnitude and direction, right? So remember, I took my upward movement to be positive. So you can decide to take it as negative, but I decided to take my upward movement as positive. So it means that the displacement also be positive. Okay. So just please note that the displacement will also be positive. But if we're looking at the movement of the ball, I'll show you now. When we're looking at the movement of the ball downwards, then this would have been negative. But I'll show you shortly. So and then force of gravity has to be negative because why? It is acting like downwards. So that's why we have negatives there. So make sure that you have like the signs correctly. Ne? So now of all of the equations of motion, which one is most appropriate given these values?
The one that doesn't have dt. The one that doesn't have
Okay,
dt.
so you mean this one, right? V squared, that's V final, U squared, V initial, plus 2 um gravity delta Y, yeah?
Yeah.
Okay. All of us are
Yeah.
happy with what I've written. Okay. If you're not happy, just let me know, ne? Yeah, unmute your mic and let me know. All right, so let's go ahead and substitute. Remember, this is the final velocity is initial. That's how I write it. Some of you may write it like this. Okay, whatever. I prefer writing like this because it's quick. I don't have to write the like sort of small I, F and I and yeah. So let us substitute now. What is our final velocity there? Speak. Unmute your mic.
Uh, zero.
0, because we were looking at the
Zero.
upward movement. So it is 0. And then what is our initial? That's what we're looking for, ne? This is what we're looking for. Then plus 2, our gravity is minus 9.8. Make sure the minus you put in the right sign. And then our displacement, it is positive 5.89. Okay, so punch this into your calculator and tell me what you get there. What do you get here? Quickly. You're very slow.
10,
You're very slow, no?
10.
Okay. Oh, someone has found the answer like that. So we take this the value to the other side, becomes a positive. Triple four is equal to u squared. All right. So we're looking for u and not u squared. So for us to get rid of this what's this square, we have to square root. What we do on the left, we also do on the right. Then u will eventually be equal to 10.74
7, 4.
rands
Yes.
meters per
7,
second.
4 per second.
All right. So
Test.
this is our answer.
Meters
So
per
that is
second.
this is the velocity that the ball was shot up with, ne? This is the velocity there. All right. Something I wanted to say. Oh yeah, look at the sign of this velocity is positive. It tells you good vele it's moving up as we took our upward movement as positive. So let's just make sure we pay attention to that. So then some of you might have done this. Some of you might have done this. Look, you might have looked at it this way. Taken this as the initial velocity at the top, the 0, and then this as the final velocity. Remember that the velocity that the ball leaves the building with here at this spot is the same as the velocity that it passes this spot. So what you could also do, how you could have also approached the problem, you would have taken this thing as your initial velocity, ne? And then this as your final velocity. That's the velocity you're looking for. And whatever answer you find, that's the velocity of the velocity at which the ball was shot up. Same thing. Do you guys see what I mean? Then how you calculate it, you just use the same method. Ne? Use the same method. Ne? Look at this. We're looking for final now, ne? Final velocity. V squared. Initial is 0 squared. So 0 squared is 0 plus 2. What is our gravity? Remember, we take up as positive. Our gravity is negative 9.8. And what is our displacement? Now, we're looking at the what movement? We're looking at the movement from the top down. So since this is a downward movement, your displacement now will be negative 5.89 because we're looking at a movement from there down. Do you see what I mean by a displacement being a vector? Yeah? All of us? Okay? Okay, V squared is equal to, this will give you positive 5.444, which will then give you the same answer.
Sir.
Okay. Yes?
So what we're basically saying is the speed at which the ball left
yeah. So
edge of
so
the
yeah, that's what
building
we're saying, Bozaya. We're saying that
is the VF.
yeah. So I'm gonna show we looked at it this way now. Ne? We took
Is
this. I'm gonna show
VF.
the first approach was we took this thing as our initial velocity, ne? And then this is our final v cortis is our final, ne? But someone might have taken this approach. I'm sure that other someone knows that like this speed here is the same speed as when the ball goes down and passes this very point. So someone might have taken this as the initial and taken this as the final and did this final v initial gravity minus 9.8 and then like displacement down minus 5.89. You see, so with the understanding that the velocity that ball leaves the spot is the same velocity the ball passes the spot with, the same spot with going down. Do you get it?
Yes, sir.
Sure. So that's something you have to know, must know. Okay, so we're
Yes,
happy
sir.
with that. Can we move? Anyone with a question? Anyone who's not happy? Feel free to ask. Okay, fair. Yeah, move on.